Hello everybody, my name is Andrew Clues. I'm the Chief Technical Officer for Semantic Landscapes. This afternoon I'm going to talk to you about our Red Hawk classification of Lidar point clouds in respect to the electrical power distribution operators and vegetation risk management. So, what do we have on the screen here? So we have a Lidar point cloud. It's monochrome in colour. It is unclassified. If I zoom closer to the section and I go down at a lower angle, we can see from the top of the screen down, we can see the acquisition flight line. We can see a range of vegetation, large trees. We can see amongst the trees in the centre and on the right and on the sort of middle leftish selection of buildings, and then we can also see the ground. And as we go in closer, we start to see the electrical conductors and the risk of how close those trees are to those power lines. And this is a large storm, potential damage to the network, and fines that accompany that damage due to customers not having electrical power. So I'm going to zoom back out. I'm going to switch now from the unclassified intensity display to the classified Red Hawk display. So what I'm showing here is about 30 minutes work with Red Hawk. It's probably about 4 or 5 tiles bolted together. This would take a human, go analyze, click, pick the data, set some parameters, probably a couple hours of picking to go and do. And I would actually honestly say it's quite a challenging area. We can see quite quickly where the conductors are in blue and the vegetation around the conductors has nicely picked out the areas of high risk. We can see the ground has been separated away, classified in the dark green. Above ground, but non-dangerous features are classified in the light green. And then the flight line, where the acquisition vehicle flew, is classified in the magenta. Now if I start to limit the amount of data that we can see, we can start to see very quickly the quality of the pick that is being provided by the Red Hawk automated tool, and we can see all those locations where cutting crews need to be sent to manage the risk on that network. And as indicated on the PowerPoint before, if I now just go to here, we can output the locations, just that vegetation, the precise geographic location. This can be output to whatever format for whatever electrical power distribution operator tool for their risk classification, where they want to send their cutting crews first, and then send their cutting crews out to the appropriate locations. So what we showed here was a very, very challenging data set. Let me just go back to the full classified result, and then back to the unclassified result. Now if we go to a different location, so first location we showed was a challenging location. This location is very simple. I think there's probably 2 or 3 tiles just bolted together here. We're probably looking at about 400 or 500 meters of data. And similarly, we can see the unclassified input. This is a relatively straightforward classification for Red Hawk. We can see the conductor going across the open field has been successfully isolated, as well as the conductor that's tracking parallel to the large hedge. If I now switch round, we can now start to see which parts of that large hedge are classed as dangerously close to the conductor. And similarly, we can output the geolocations, and you can see there's a nice parallel edge to that vegetation, mimicking the shape of the conductor. And if I just hold up to the slight angle and I bring all the data back in, we can start to see that parallel edge is nicely fitting to the data. Okay, I hope that's a good demonstration for everyone. In conjunction with the PowerPoint that was presented earlier, if you have any questions, please ask. Thank you very much.